Okay, so there's more history for you here on here. Let's go. This guy Dexter, he has his an own algorithm named after him, which is also in this pack. Apparently he's on YouTube. I'm not sure they are still alive anymore. But if you want to fill in the gap, it does the same thing as Kruskal's algorithm. It finds the minimum spanning tree of a network. Again, there's steps listed in your pack for how you do this. The big difference between Prim's and Kruskal's algorithm. Kruskal's algorithm is concerned with the arcs of a network. Prim's algorithm is concerned with the node, with the points. Okay, so P for Prim's, P for points, that's how I remember it. And Prim's algorithm, you will be kind of joining it up as you go along rather than adding on random arcs. I'll do an example again, which will make more sense. We're doing it on the same network as before. We will get the same answer. We'll get the same minimum spanning tree, just a different way. So for Prim's algorithm, you will be told, usually, not in this one, you'll usually be told where to start. Okay, so we're going to start at point A, but it'll usually tell you in the question where you're going to start. Yeah. And what you do is you look at point A, you look at the arcs that are connected up to point A. So you've got to consider AD for 20 and AB for 19. And you add on the shortest of these, which doesn't form a cycle. Okay, so we're going to add on AB first. Again, we're listing the arcs in the order which you add them to your tree. It's even more important for Prim's algorithm that you list them as you go along. Okay, because if you forget and you get to the end, you're going to realize you're just going to have to do the algorithm again. Yes. At Kruskal's, it's fine. You've ticked them all as you went along, but Prim's, you've got to do it as you go along. Okay. So the first one we're adding on is AB, so make sure you write that down as you go along. We now repeat the process, including the new node that we've connected up. So now we've connected up A and B. We look at all of the arcs that are now connected up to both A and B. So we consider AD for 20, we've got BD for 12, and BC for 13. And out of those three that are now connected up to A and B, we choose the smallest, which is going to be BD. Okay, so we add BD to our minimum spanning tree. We add it to our list of arcs that we've added on. And repeat the process. So now you're looking at three nodes. You're looking at all of the arcs that are connected to each of these three nodes, A, B, and D. And you're picking the smallest out of those that doesn't form a cycle. So now we can't add on AD because that would form a cycle. You wouldn't anyway because it's the biggest one. You could add on DF for 10, DE for 12, DC for 15, and still the other ones from before, you could still have BC for 13. Obviously, the shortest out of those is DF for 10. So now we're going to add that one on to our minimum spanning tree next. And as you build this up, you've got more things to check. So make sure you're really, really careful that you do check absolutely every possibility that you can add on. Now we're looking at all the arcs connected up to A, B, D, and F, and the shortest out of those. Well, now we've got F in, the shortest is going to be F to E, so FE is our next one. Add that to your list, add that to your diagram, and now we just need to work out how to connect up C. So the next shortest arc that connects up to all of these is this ED for 12, but that would make a cycle, so we can't do that one. Instead, to connect up C, we want BC, and that's the 13. That's the shortest way of connecting that up. You could have EC, you could have DC, but that's 14 and 15. So BC is our final one that we have. Again, it asks for the weight of your minimum spanning tree, so add up those arcs. You get 62 again. You get the exact same minimum spanning tree. It's just a different way of doing it. The Prim's is concerned with the points. You're looking at all the arcs that are considered connected up to the points, whereas Kruskal's is concerned with the arcs.